Okay, so we're into the amplifier now, finally. We're going to replace all these caps here with the radial caps. This is the base of the big can capacitor. This is 4 separate caps. 2 of them have the same value and the other 2 are different. So this one's going to be tricky. I still think that I probably have plenty of room down here to put all of these caps. But what I'm going to do on this one, I can't really see the little triangles and squares and circles all that well. Again, that's referenced on the side of the can. So I'm going to verify on the schematic which lead. Obviously all the grounds go to chassis, and I need to verify which lead goes to all these individual lines out. The easiest way to do that is to check on the schematic and see where these resistors tie in. So you've got a resistor there, one here. So I should be that drops everything, and then the other one's on yellow wire that goes this way to this. I don't know. There's a dial or something there, an actual potentiometer. But anyways, the once I figure that out, I'll, like I said, tie in all those caps on the bottom. But the difference with the amplifier versus all the tuners and everything is that while I'm in here, I'm going to be checking all these resistors. So lots of these little carbon resistors, we're going to check them to see if they've drifted out of tolerance. Anything that's above 20% of the original value is out of tolerance. And you can check what the resistors are supposed to be by looking up a chart, and you'll see this little code with all these little rings on it. And you have to look up the chart and see what they're supposed to be. If it's more than 20% of what it's supposed to be, then I will order replacements, or maybe I have some. I have a few things, but probably end up ordering some if I do need them. But so that makes this part a little bit longer, but fortunately every time you desolder one of these leads to do the new cap, all of a sudden I have an open lead on the end of the resistor, which means that I can test it. I can't test them in circuit because there's other stuff that's adding resistance and that skews it. The other way to open a lead on these is like this right here, ends on a tube socket, and you can just pull the tube out, and then I can test that because it has an open end essentially. So that's it. We'll just go through and start doing all of these, and hopefully all the resistors look good and I don't have to order any, but I might. I can always order them and then do some other things while I'm waiting for them to show up. Okay, amplifier is done. See how I hacked all these caps in line here? I just clipped the leads off, twisted, resoldered. People call that hack job stuff. I don't give a crap, honestly. It works. It makes the amplifier work. It makes it not catch on fire. It makes it not burn out output transformers. I think that's the whole point. So here is the big those are simple, straightforward radial polymer caps. It's real, it doesn't matter which way the leads go. Clip, twist, solder. That's it. That's all there is to that. Here's the electrolytic. It does matter which way the leads go. The negative terminals go to ground. In this case, there are some amps that are positive ground. This one isn't. This is negative, so that's normal. So what I did here is I cut all of those leads. There's 4 leads off the big can capacitor. Chopped every one of them. I took the negative leads off of these 2 caps and put them straight to that terminal, which was part of the can. Took the negative leads off of that cap and that cap, put them straight to the can right there. You want to make sure these joints that go to chassis ground are really good and solid. I think that's a common place to get a cold joint, but having a good soldering iron certainly helps. Is probably the most important part. So the positive leads off of each of these caps come up, and I put a little tubing, spaghetti tubing on here to keep the positive leads protected because things start getting pretty tight. You can see the joints where I did it here and here, and this other larger cap to ground, and here's a really small one, but that was part of the can too. So as you can see, the new caps are much smaller and fit right underneath the chassis. Didn't have to get too crazy. Again, some people would say, well, that was very hacky of me. You could, take the can all apart and restuff it, and then it would be all original and look all cool. Well, I don't give a shit about that. I want the amp to work. That's all that matters. So, in this process, I realized after doing all this that I missed a cap in the tuner. So, right here's the tuner. That right there was something I missed. The reason I missed it was because it was underneath here. Didn't see it, obviously. And the reason I figured it out, actually, is because it was left over. Everything else was bipolar, non-polarized caps, which means those were for the speaker crossovers. But there's this one electrolytic left, and it goes right there. So I would have never known that had I not had the Sam's photo fact, which I guess is something to think about. That's why I like doing it that way, getting the manual first, unless you absolutely can't find it. I don't like paying for them, but sometimes I do. Just depends. So anyways, that cap's going to be switched out next. That's the next step, and then we're going to start doing some deoxit. Okay, so now we're going to use some deoxit in two spots. The first spot here is the tube, the actual tube terminals and the tube socket. You just spray it right on the, we just spray the stuff right on the tip of these probes here, and basically push it in and out of the socket. The other spot is in all of these potentiometers, or these dials. You spray it right down in a really small, wherever you have access to the plate in here. So there's these really tiny little holes on the side of these things, and you spray it in there and you basically work the dial back and forth. So the stuff just dries out. You just actually put the probe in there and spray it in like that. And it seems weird because you're getting things all wet, but it evaporates, dries out, so it's not going to cause any problems. So those are the two things you want to do with deoxit or contact cleaner. Everybody swears by deoxit, so I finally bought a can when Radio Shack went out of business. So I should have bought more probably. But I've always used other stuff in the past and hasn't really caused me any problems. This stuff's supposed to be the best. So that's another thing you got to do. Clean all these pots and switches. Spray every one of them out. Sit there and twist it, 50 times or whatever. However many you want to do. And then also clean the tube sockets and tube terminals. So after this, we're going to do the crossover capacitors in the speakers. Alright, crossover caps are the final two capacitors we're going to be replacing. If I can get this thing to focus right there, that is a 16 MFD or 16 microfarad 25 volt non-polar. Now this is interesting because this says 25 volts, which makes sense for a crossover cap. They really don't need a lot of they don't get a high voltage demand on them. But in the schematics on the Sam's photo fact, when I went to order these caps, they were listed at 650 volts, which is really high and kind of bizarre. So I was reluctant to find and purchase the readily available options from Mouser. So I ended up finding some higher voltage ones at 100 volts, but it's really not necessary. Either way, again, you can go up in voltage on caps, it doesn't matter. In this case, instead of buying a 16 microfarad cap, what I ended up doing is I bought a bunch of individual caps and I'm going to be paralleling them. So this is a 10 microfarad, that's 4.7. This is a 1 microfarad, and that's 0.47. So that puts me not at 16, but ever so slightly above 16, which wouldn't matter. This cap's only in place to block the lower frequencies from being delivered to these smaller speakers. So it's just a crossover cap. That's the only reason that it's there. So I'm going to do some paralleling on the bench. I'll show you what that looks like. These are non-polarized, so I don't have to worry about which direction we're going, but I enjoy paralleling caps. It's fun because the solder runs really nice and makes some creative things. It's much cheaper to do it this way. I could go to like Parts Express or Simply Speakers and buy the two caps that I need, but then you got to pay their $10 shipping, so it ends up costing you $20 just to get the two caps. Whereas I was able to throw these all on the pile of stuff from Mouser, and I'll just do a little extra work paralleling them all together, and that only cost me a few dollars. Okay, so this is what the original crossover cap looks like. You can see that it has a mount here, and it has this little terminal on that end, and it had this little line on the other end, and this is what I built. A close-up of the hack job. So that's 4 caps there, all ran together right there. All the leads are connected. Of 3 of them were soldered to the leads off of one of them. All the leads are split right in half right off the top of the cap. Now these are all vertical mount capacitors, radial mount rather than the axial mount. The kind of axial mounts are actually easier. This is a lot easier to do. The way I did this was kind of crazy. Every time I do something, it ends up looking slightly different. This is just a weird like star pattern to get them all to fit on there. I smashed the old capacitor's mount and zip tied the biggest one onto the top, as you can see. But anyways, it's a total hack job, and but it only cost me $1 or $2. So I really don't care. I don't, I could have bought a bigger single capacitor and paid, $10 for it. It made everything look as close as possible to original. I could have stuffed other capacitors inside that one, but who cares? It doesn't matter, because the point of this is to block frequency, not to look nice. So again, nice and hacked up, but all the solder joints are good. We'll have a good connection on there, and it'll sound exactly as it's supposed to. And there it is in all of its hacked up glory. All mounted in place. Looks like crap, but it's gonna work just fine. So we're almost to the home stretch now, the final bit where I throw everything back in here and fire it up for a test run. Super exciting and a little bit nerve-wracking, because if it doesn't work, then I made a mistake somewhere and I've got to trace my steps. Some people say do one thing, turn it on, replace one capacitor, turn it back on, replace another capacitor, turn it back on. This is a great idea in theory, but how do you do that after pulling all of the components out of the system? Practicality? No, not really. 1 amp board at a time might have been a good way to do that. But I don't know. I've always done it like this. As long as you get really good solder joints, then you keep everything aligned like it's supposed to, then no reason not to just shotgun the whole thing and throw it all back together again. So